most important thing here now is that you have to share this video so that many persons can have access to it. Because there are so many JAMB students now who are lost, okay, who are confused about how the exam follows. I'll tell you the patterns. That's why it is integration hacks. JAMB follows a specific pattern. JAMB does not change their pattern. Okay, just like leopard does not change its skin, JAMB does not change its pattern. In fact, I will show you a particular question that was repeated verbatim. The question was repeated. The question was let me show you. Yeah, the question was repeated. Okay. The question is this. After this, we are going to look at it so that we don't waste our time. All right. So the question was actually repeated, and I'm going to show you this. So I hope this is understood. Please do well to bring in your questions. If you have any questions, let me quickly know so that I proceed to the next one without wasting time. Right? Any question? Any question? So if there are no questions, so let me check in the chat box if there are any questions. Please, if you have any questions, let me know. Okay, I'm still waiting for you. Okay, please do well to engage me. Engage azsciencetv. Okay, I'm very happy to have you part of this. So it's very simple. Let's look for a similar question. Okay, a similar question so we can move very quickly, very fast. Because today we are moving at the speed of nanoseconds. Yes. Very fast pace. So let's look at this. The questions are always very quick, quick snap. So look at a question like this. Evaluate. We have to evaluate integral 2 open bracket 2x minus 3 then 2/3. Look at this. This is the x. So how do we handle something like this? I'm sure you can see how this kind of question can come, right? So how do we handle a question like this? It's not simple. So this is what we are going to do. You see that this question is similar to the first question, right? Yes. They only added something here, which is the same thing. Don't let anything bore you, okay? The two has no serious implication. So look at what we are going to do. Here we have 2, then open bracket 2x, then minus 3, then 2/3. Okay, this is the x. So we want to integrate this. When you hear the word evaluate integral, it means integrate it. If there are numbers here, it means it's a definite integral, and we have to substitute after integrating. Then don't forget the constant, arbitrary constant, except if it's a definite integral. Right? So let's proceed without wasting much time. We already have 2 here, so don't bother yourself. Who's 2 here? I said let's repeat everything, right? So let's repeat. That's 2x minus 3. Then we are going to raise it to the power of this. That is the exponent, right? Yes. This is what we are going to have. Then what do we do next? Add 1 to the exponent because we are integrating. We increase here by 1. Then add the total of this right here. This is divided by 2 divided by 3 plus 1. Then plus c. C is the arbitrary constant. Remember I said the arbitrary constant is the constant that has to come in because we are not sure. We don't know the number, but there was a number there. Okay, so that is arbitrary constant. Is that taken? So if you have any question, please do well to put it in comment section. JAMB candidates, please join me if you haven't. So let's proceed now, right? What is 2/3 plus 1? As a JAMB student, transfer this 3 here. Okay, if you transfer this 3 here, it becomes 2. Right? You just draw a line like this. Okay, this is 3. This is the only number at the denominator. Then transfer the 3 here. 3 times 1 is 3. Okay, it becomes 2 plus 3. Okay, that's all. What is nothing? This becomes 5 divided by what? 3. That's what we have. So that is what will be here and here. Okay, 5/3. Don't waste time. Too many LCM will waste your time. Okay, try to understand the trick. So JAMB will not give you anything that is that's too difficult. Okay, so this is 2x minus 3. Then what is here? This one here is equivalent to this. Don't forget, that is 5 divided by 3. Okay, that is the exponent. Don't forget. Let me write it properly. That is 5 divided by 3. Then here we also have 5 divided by 3. This is what we have, okay? I hope it is clear. If you have any question, please let me know. Put it in the comment section, okay? And if you can hear me clearly, let me also know. I want you to engage azsciencetv so that we can all be working together. Please. So what do we do next? Transfer these 3 to this place. Transfer 3 to this other place. Okay, that gives us 3. If you move the whole of this here, you invert it and bring it here. As a JAMB student, you need to know this. Just move the whole of this to the numerator and invert it. So it becomes 3 times 5. Okay, becomes not 3 times, it becomes 2 times 5 over 3 times 3 over 5. This is what it becomes here. Then we have 2x minus 3. Then we have 5 over 3. This is what we're going to get here. Okay? Because we have transferred this denominator to the numerator. So we have to invert it. As a JAMB student, you need to know these tricks. These are very important so that don't waste time in the exam hall. Okay? Remember, JAMB has no much time. You don't have much time when we are in the hall. There's no much time. So we can go ahead. Remember our plus c, okay? Plus c. So 2 times 3 is 6 divided by 5. That means that we have 6 divided by 5. Open bracket. Repeat everything else, and that gives the answer. Okay? That is 2x. Okay? 2x minus 3. Then this is 5 over 3, right? So that will give us 5 over 3 here. 5 over 3. Then plus c. Or you can call it plus k. If you don't want to write plus c, then it can be plus k. It depends on what you find in a JAMB question. So that's exactly what it is. Do we understand? Yes, if we understand, please, if we are following, let me know in the comment section. I would like to hear from you because you are the most important participant here. Okay, I'm only opportunity to be here because of the present state, but possibly I could be watching your content too tomorrow. So please do well to let me know if you understood. I want to see in the comment section I understand, and if you don't understand, let me know what else can we do, and what other suggestion do you have to make it simpler. Why not just put it in the comment section? Okay, and I'm more than happy to have some of these suggestions because we welcome suggestions a lot. So thank you very much for watching. I do know that your presence here will change everything today. So I want you to comment. Okay, comment, let me know what we are doing. So we are going straight to the next phase. The next phase is what I call definite integrals. But before I go there, let's look at integration of trigonometric functions. Integration of trigonometric functions. So let's look at trig functions. That's where we are going to right now. Trig functions. Please, we are going to be very fast today. Please, because we have a lot to do. Okay, just bear with me. I'm going to be cleaning this space. No, we don't have much space. So now let's look at this integration of trig function. Look at this integral. Okay, we are going to evaluate. Evaluate integral sine 2x dx. Yes, evaluate integral sine 2x dx. So how do we evaluate this? So this is very easy. I'm going to show us a simple trick. Yes, remember I told you this lesson today is all about tricks. Yes, JAMB is a tricky examination body. So if you want to defeat JAMB and win everything they are hiding from you or from us, we have to use tricks and hacks. Now look at this question. Very, in fact, we don't even need to bother ourselves about this question. I will just show you just one slide we are done. Do you know that JAMB repeated this question? As in word to word, everything, verbatim. This question was repeated in 2 years. I don't know. Yes, it was in 2014. Okay, this question, go to 2014, you will find these same exact questions in 2014. Then they now went to, JAMB still went to, let me show you again where they repeated it. JAMB still went to another year, a particular year again, and repeated it, 2005, yes. This question was in 2005, and it came out again, verbatim, okay, just the way it is again. It came out in 2014. Yes, these are the 2 years that JAMB repeated this question. So JAMB can repeat questions, all right? So don't forget that. If I had seen where JAMB repeated NECO question, they went to NECO and copied the question verbatim. So that is why all the exams are connected. Now let me show you the trick. Don't waste time. There is no time at all to waste. You see these two here? Okay, let me not bother you, okay? Differentiate what we have here, dy dx. What is dy dx of this one? Differentiate it, use it to divide sine x. Okay? So change sine x to cos x. If you take sine x, it becomes cos x. Cos, right? Not cos x, cos 2x, because it is cos 2x, right? But when sine is changing to cos, when sine is changing to cosine, it will be negative. So we are going to bring in negative here. Then divide it by dy dx of what we have here, of the angle. Let's call it the angle, okay? Whatever we have here is the angle. That is dy dx of, sorry, okay, let's not call it dy dx. Let's call it d dx of 2x. Then plus k. Let's call it plus k now. Okay, I call this, remember I call this c before. I place c here, but I'm putting k now to let you know that JAMB can come in different form. Okay, but they are the same pattern. Now what do I mean? This k is the arbitrary constant, don't forget that. So we can now go ahead, differentiate this. If we differentiate 2x with respect to x, we are going to have 2, which means we have minus 1 over 2. Okay, minus, this is minus 1 over 2 cosine what? 2x plus k. Can you see it? So there is no need bothering yourself for doing function of a function or this or that. There is no need for all of that. Just understand the tricks. Okay, if it was to be differentiation, we would have differentiated this one and multiplied by cosine. Okay, and cosine will be positive. So that's the difference. Try to learn the difference between integrating a trigonometric function and differentiating a trigonometric functions. It goes a long way to help us understand these tricks and how to wire them without wasting our time. All right, so we are here to make sure that we don't waste our time when it's JAMB. Remember, it is JAMB season. So when that time comes, we don't waste time. That's why we are here. Now, we go to the next trick or the next question, okay, on this integration hacks and calculus tricks. So I hope we are actually following this question, okay, and the solutions. Please, I want to see your comments. I want to see your chat in the box. Okay, nobody is chatting me. I hope we are not angry with me. Please do it to chat me. I want to see your chat. Your chat will make the difference. Your chat will make the difference. So please do it to chat. I want to know if you have suggestions, if you have questions, if you have any statements. Why don't you just say hi? You can say hi, okay? Let me know who you are. Okay, I love addressing my viewers by their names. Right? It goes a long way to make the class better. Okay, the class will be better if we are together. and we can only be together if we know each other. Now, look at this question. We are to find, yes, we are told to find the integral of sine x plus 2. Then in bracket, we have dx. This is another question, right? Yes. So we have a constant here, okay? Then we have a trigonometric function here. So the both of them are added together. So we want to know what the answer will be. What should be the answer? Who knows the answer? If you can solve it, put it in the chat box, okay? Just put hashtag. There's no special question and answers section. So put hashtag and ask the questions, okay? Or if you want to chat me, just put hashtag, hashtag whatever you want to say, okay? That will be better for us to communicate better. I just don't want to create that section because that section limits a lot of other things. So that's why I want you to use the direct method of hashtag question, hashtag suggestion, hashtag salutation, hashtag anything, all right? So that we can move very quickly, not to waste our time. So let's proceed to this. But before I proceed, let me just write it, then I'll tell you what I'll tell you now, because I have some secrets to let you know, because JAMB has a lot of secrets, which is why most students are finding it very difficult, because there are some secrets. They know that once you know their secrets, it will be very difficult for them to trick you. You understand? That's what we're saying. Now, there is what we call standard integrals. If you know standard integrals very well, these things won't be a problem. Okay? Remember, standard integrals are the integrals that have been lined up for every bit of steps you must take. So sine has a standard integral, cosine has a standard integral, tan has a standard integral. Okay, so you need to know all of that. If you know it, then there will be no problem. Then sec square theta has its standard integral. Please do well to learn the standard integral. I will tell you where it's going to be very fast. If you like, this is a standard integral. You don't need to be doing any other thing. So let's say we have this. This is sine x. Change it to cosine x. Cosine x. But when doing that, sine to cos is always negative. That is why you need to learn the standard integrals. If you learn standard integrals, then you will know that sine to x is what? And sine to cosine is negative, while cosine to sine is positive. Please note this, it's very important. So, which means we are going to add minus here. That is the implication. We are going to add minus here. Then, this is plus. Don't be opening brackets. There's no time. This is not WAEC. This is JAMB. Okay? I advise students not to be opening brackets because there's no time to be opening brackets. Just integrate this one with respect to x. You are simply going to get 2x. This is what we are going to get. Whenever we integrate a constant, okay, with respect to anything that is here, if it's theta that is here, it becomes 2 theta. If it's anything that is here at all, just integrate it with respect to it. It becomes 2 of that thing, okay, 2x. So that's why we have 2x here. Then plus k. Yes, you can call it plus k, or you call it plus c. You can write plus c, which is the arbitrary constant. This is the simple way to present this answer, okay? This is one simple way to present this answer. So it's quite easy. So I do hope it's well understood. Please chat me up. I want to know how you see the lesson. How is the lesson going? Okay, are you preparing for JAMB? What are your difficulties? Are you seeing something like this scary? Is this scary? Okay, let me know. Okay, if you have any other thing to say, why not? Go ahead. I want to know. We are going to dissolve a lot of questions in this class. The class is a 2-hour class, so I want us to break calculus to the core. Yesterday, we dealt with differentiation. Today is integration hacks. Yesterday, it was differentiation hacks. Now, there's something I want us to know, which is very, very important here. Now, JAMB has not failed. JAMB has not failed to set questions on definite integrals. That's why this class, we are going to deal decisively with what? Definite integrals. These integrals are called indefinite integrals because there's no numbers here up and down. Okay, but JAMB has not failed to be setting definite integrals where you have numbers here and there. It's very common in JAMB. I have seen all the years. JAMB is always setting questions on definite integral. So we are going to look at that. But what about standard integrals? Yes, what you call standard integrals. Before I now go to definite integrals, let's look at standard integrals. Okay, then from definite integral, we'll now go to application of integration. We'll pick like 2 or 3 questions, and that will be the end of the class. All right, but definite integrals are very important. Now, let's look at integration. Okay, what is the integration? What is the integral? Standard integral, please. What is the integral of cos x? Yes, the integral of cos x is what? Okay, now what is the integral of sine x? You need to know these little things. If you don't know them, if you cannot differentiate between them, you will see that you'll be having some issues. It's compulsory, you must have issues if you don't differentiate between these two. Okay, don't make that mistake. Okay, that's why I'm here to lead you, and I'll tell you how to do it, how to differentiate between the integral and the differential of cos x and sine x. Okay, now you know that this is cosine. That's from cos to sine. Okay, from cosine, we call it cosine. So cosine. You see this? Cosine is positive. You see that now? It's positive. Now, this positivity only holds during integration. Okay, from cosine. But if you now have sin cos, or yes, sin cos. Okay, sin cos, something like this. This one only holds. It only holds. This is positive. This is positive for integration. This is positive for differentiation. So you need to understand the difference. Cosine, because this is cosine. There is no trigonometric ratio called sin cos, but there is a trigonometric ratio called cosine. Okay, and that only holds for that is only positive for integration and negative for differentiation. So please note this, it's very important. So since we have cosine, which means from cos to sine is positive. So this is cos to sine. This becomes sine x plus k. We are adding the k because it is the arbitrary constant. So thank you very much. I hope this is really educative enough. Let me know in the comment section, okay, if it's informative and if you are getting anything from the class. Then this is sine x. This sine x going to cos x will no longer be positive. Instead, it will be negative, which means we are going to add minus here, then plus the k we have here. You know what JAMB can do? If you are not careful, you know that JAMB can bring this k here. Look at it. It will not be k minus cos x. Do you know that it can come in this form? These people are very tricky, so you have to be tricky as well. All right. So they can come in this form. Instead of putting the k here, they'll bring the k here. This is also plus k. This is plus k. You see that? So it can come in this form. Whichever form they come, don't worry, it's same pattern. We know them already. Okay? And we are going to tell JAMB this time that by God's grace, we are coming to score 300 plus. That is the purpose of this class. So that is for this. What about integral? What about the integral of sec square x? Yes. What is the integral of sec square x? You must know it. Please find a way to get it. All right. So the integral of sec square x is tan x. Is tan x. The integral of sec square x is tan x. Then plus the k. Plus k. This is very, very important. Okay, please don't forget that it's very important. So learn other integrals too. Learn all the standard integrals so that you don't get into confusion, especially when JAMB confuses students. This JAMB is going to be very interesting, okay? And you'll not find anything difficult because I'm going to show you so many tricks. Now we go to what we call definite integrals. Yes, definite integral. Definite integral. When we say definite integral, means integration that is done within a particular range, okay, from 0 to 1 and so on. So let's look at definite integral. Definite integrals. Now, in some of my videos online on azsciencetv on this channel, I gave some very important JAMB questions. Do well to watch it. I'm going to link that video to this particular video, okay, and find a way to link it to other videos. So I stated some very important topics, and calculus is one of it. There is no year you will not find up to 5 questions, at least 5. I have checked a particular year where I got up to 6 to 7 questions in JAMB. Imagine you have a question given, okay? If you have 5 questions per topic, 5 questions per topic. Now, and you read 5 topics. You see, you have 5 questions per topic, and you read 5 topics, and each of the topics you read gave 5 questions. Multiply and see. Out of 40 questions, you've already gotten 25 questions in the exam. So that's why you have to understand the topics. Know the topics that are very crucial and that takes more, that brings in more questions in the exam hall. If you know it, forget it. Okay? You don't need to read all the topics to pass the exams. You need to read the crucial ones, and that is what we are going to be exposing in this class. Okay, because the time for JAMB is very close. So you need the hottest topics. So I call it the 6 JAMB hottest topics. Just go and look at the topics. You will see it there. The 6 JAMB hottest topics. Calculus cannot be taken away from it. Okay. Now let's proceed. The next one is definite integrals. Now definite integrals are integrals that are made within a particular range, just like I earlier said. So I'm going to give us this one. This is a very simple definite integral question. So let's look at this question. Evaluate. So we are going to evaluate the integral. Okay, 1 minus 4 here of 1 minus 2x dx. Now we are going to evaluate this. You can see that this is a definite integral because it has a definite range. We are starting from minus 4 and we'll end at 1. These questions, these type of questions are always coming out, almost every year. Okay, out of every 10 years, you will find this type of questions 8 to 9 times. It comes out 8 to 9 times. So in this pattern, it may be 0, 1, it may be 0, pi, it may be minus half, you know, but it's usually in this type of pattern. That's why I said in this class, we are going to emphasize more on definite integrals. So let's look at this question in this solution. So let's proceed. We have integral minus 4, 1, open bracket, 1 minus 2x, then dx. Okay, this is what we are going to do. First, we are to integrate the algebraic expression. This is an algebraic expression, right? So in calculus is majorly algebra. Yes, obviously it's algebra. So let's integrate this. When integrating, we may not bother putting the arbitrary constant k. So if we integrate this one here, it will become x. Integrate it, it becomes x minus, integrate 2x, becomes 2x squared divided by 2. Okay, remember this is 2, this 2 is here, okay, the 2 is still here, so you have to increase this by 1. So add 1 to 1. Remember there is 1 here, there is 1 right here. There's 1 here, so we are simply adding 1 to 1. That's the meaning. Okay, which means this is 1 plus 1. This one that is here too, this 2 is here. So let me differentiate it so that we can follow up the class. Okay, then this gives us x minus 2x squared, right? 1 plus 1 is 2, then divided by 2. Okay, this 2 is going to cancel this, right? So if that cancels, means we are going to have x here written like this. Then minus 2 has cancelled 2. We now have only x squared left here. X squared. Don't forget that it is a definite integral. So we take minus 4 to 1. Just always write it like this. Minus 4 to 1. You can see that there's no need for the arbitrary constant. K, that K we are writing, or C at the end of this place. We don't need it anymore. So this is the, okay, this is minus 4 to 1. Now it is time for substitution. We are going to begin from this bigger one and end at the smaller one. So to substitute, we are going to set up 2 brackets. Don't forget, it's usually 2 brackets. 2 brackets. So here is x, right? And x is 1. We are starting with 1. So this 1 minus 1 square. You get it? This is 1 minus 1 square, just for 1 alone. Then the second bracket is minus 4. We have minus 4. Then minus, this minus, okay? This minus. We have minus 4. Then this is minus 4 minus brackets minus 4 again. This is what we are going to have. Okay, this minus 4, this second minus 4 will be squared because it has square here, just like we squared this one here. So come here, square minus 4. No need in JAMB, you don't need to waste time. So I'm here to give you the tricks now so that we don't waste time. I'm just breaking it down, but there's no need for that. This is 1 square. 1 square is 1, and 1 minus 1 is 0, right? Is 0. So which means we have 0 here. Minus, okay? Minus. Then what is here? Minus 4. Yes, minus 4 is here. Then minus times. Don't use minus times minus, please, because there is a square here. So the square of minus 4 is 16. So we write 16 here. I'm sure you know why this minus is here, because of this minus. This square has cancelled this minus. We are now going to have 0 minus, if we handle these two together, combine them, add up the negatives, we have minus 20. Minus 20. So our final answer is 0. Okay, 0 plus 20. Okay, which is equals to what? 20. This is the value of this integral when properly integrated, and these definite values substituted. When they are substituted, this is what we are going to get. Okay, but in JAMB, you don't need to follow this pattern the way it is. Just skip some patterns, skip some parts, skip some steps, and get your answers. But if you cannot, then you have to be very fast. Okay, the hacks is what I'm here to teach you. All right, so note the hacks that this one we cancel each other here, so we don't really need to bring in 1. JAMB knows that we don't need to bring in 1. Okay, we are not bringing in 1 because this is 1 minus 1, 0. So this, instead of JAMB giving you 0, they just put 1 minus 1 here, which is 0. So which means you are starting with minus 4. This first bracket here is not necessary. That is a trick. This first bracket here is not necessary because it will give you 0. Anything that will change to 0 is known as the vanishing trick. So we don't need it here. So start from here and get your answer straight. This 20 you are seeing here actually came from this place, not from this first bracket. Okay, so thank you very much for watching. I do hope you got everything I'm saying. Please, I need your chat. I need you to talk to me. I need you to chat me up, because without the chat, without me being chatted, means that I am talking to myself. Okay, I don't want to talk to myself. Please, I don't want to talk to myself. I want you to join me. Please do well to subscribe if you haven't. Okay, more classes coming soon. More expository classes coming soon. So I'll see you. I'll keep seeing you. I'll keep giving you the tricks on how you can pass your examinations, whether it is JAMB, whether it's SAT, whether it's G in India, or whether it's London GC, GRE in USA, SAT in USA, London GC, or any other examination. I am here to make sure that you pass all of them in flying colors. Now, the second one is this. Let me bring in this one too. I'm going to this another question. The question is evaluate. It's usually, that is the pattern, okay? Evaluate. JAMB always use the word evaluate. Okay? Evaluate integral, definite integral, 2 to 3. Then here we have x squared minus 2x, then dx. This is very, very crucial. Okay, very, very crucial. So we have to evaluate this within this range. So this is a definite integral, and it is JAMB question. So how do we solve this? If you know you can do this, let me tell me now. Yes, if we know we can do it, let me know in the chat box there. Yes, there's no special space for answer, question and answer. Okay, just do everything. Ask your question in the normal way. Just put hashtag, then ask your question. Hashtag question, hashtag answers, hashtag suggestions. Okay, hashtag salutation or any other thing. Just hashtag, okay? And let me know your take in the class of today. And you are all watching, but nobody's commenting and nobody is chatting. I want you to chat, because when you chat, it becomes better. That's when we know where we are going to and the directions. Okay? So I wish you the best and excellence in your exams. And if you're not writing an exam and you are here, why not? It means we are all learning together, definitely. So we are also here to learn together. This x squared minus 2x, then integral dx. So this is what we have. So can you tell me what the next step will be? I want to know what should be the next step. What do we do next? Put it in the chat box. Let me hear from you. Let me see your own take. So put in the chat box, what is the next step? What do we do next? Okay, I want to know in the chat box. Please, I need subscribers, so I want you to subscribe. Okay, this is a free lesson, so I need you to also find a way to subscribe so that we can all move together. Thank you very much. This is definite integral. Another question on definite integral. Yes, because we have range here from 2 to 3. We are going to begin by integrating this. We integrate the algebraic terms inside the bracket, then substitute these values. So let's begin. This is going to give us x raised by 3. This is x raised by 3 minus 2x squared over 2. This is what we are going to have. Then the range is what? From 2 to 3. So from 2 to 3. That is the range. That's why it's called definite integral. Now there's no need for the k, because we have already brought this range here. The k will cancel each other. Now let's proceed by creating two brackets. Remember, I said we're going to create two brackets. But before then, note that these two will cancel each other, right? Yes. And that will now give us what? Let's put the values here. Okay. The values will now be, the algebraic expression will now be x raised to power 3, because we are adding 1 to these 2 to give 3. Then minus x raised to power 2, because we added 1 to this one here to give 2. Whatever you add here, also do what? Divide here. Here, also divide here. Okay? You must always divide with the new exponent. So that's what we did here. So this one has been cancelled by this. We don't have 2 again here. Then go ahead, put in the range. Okay? The upper and the lower limits. Put them there in the range. So we are going to, I apologize if you can hear some noise, okay, from children, because we are in a school. Please bear with me, okay? Please, I appreciate you for joining me. So this is 2, this is 3. We are starting with the bigger number. We'll substitute here. But before then, this is what we are going to do. Don't forget, as we said earlier, 2 brackets will be created. Create 2 brackets. This is minus this here. Yes, I hope this is very clear. If you can see it properly, please let me know. Put it in the chat box, or put it in the, yes, chat me up if you can see this very well, because I want to substitute the values for 2 and 3 right here. This will help us for better understanding. So this is x raised to power 3. X raised to power 3. And this is 3. We'll start with 3. So that's 3 raised to power 3. Write it here. Write 3 raised to power 3 here. 3 raised to power. Okay, let me write it properly. We have 3 raised to power 3. 3 raised to power 3. Then divided by 3. This 3 here. We are going to write 3 here. Then minus. Okay. Remember, this is minus. So this is also 3 raised to power what? 2. 2. So we are done with 3. We'll come to 2 and do it here too. Okay. So what is that of 2? And whenever you find 3 here, replace with 2. Or not necessary. Let's come here so that we don't get confused. Okay. So here is 2 raised to power 3. That is 2 raised to power 3 divided by what? By the 3 we have here. So we have divided by this 3. Then minus. Okay. This is minus. Minus. Then this is 2 square. 2 square. You can see it. So if we go ahead solving this, what is it going to be? 3 raised to power 3 is 9. Okay, this is 9. So this will give us 9 here. Okay, that's 9 divided by what? 3, right? 9 divided by 3 minus what? 9. This is 3 raised to power 3, sorry. That's 27. That's 27. This is 27. This will give us 9 later. So let's proceed. And this is minus what we have here. Okay, what do we have here? We can do it like this. 2 raised to power 3 is 8. This is 8 raised to power 3. Then minus 2 square is 4. So we are going to have 4 here. Then close the brackets. Okay. So 27 divided by 3 is 9, right? So this gives us 9. Please permit me to come this way. I'm not a left-handed person. I'm a right-handed person, okay? So 27 divided by 3 is 9, then minus 9. I can write faster when I'm in this position, okay? Just bear with me. Now, notice that these two will cancel each other, right? Can you see that? So because they are gone, we are now left with 8 divided by 3 as this. Remember the style I told us, right? 3 times 4. 3 times 4 is 12. So that is 8 minus 12. Don't forget, that's 8 minus 12 divided by the 3 here. Okay, that's 8 because 3 times 4 is 12. So 8 minus the 12, then divided by 3. There's no time to be wasted here. So this one is already gone. We now have minus open brackets. 8 minus 12 is minus 4, right? Divided by 3. Divided by 3. Yes. So what happens? to the minus. The minus disappears, right? So we are now left with 4 divided by 3. This is the final answer. You can put it in mixed fractions, or you leave it this way, or decimals, as the case may be. Depends on what JAMB has placed there. Okay, any answer you find there, or any other examination, not only JAMB, because this examination usually copy each other. They copy each other's question, copy each other's pattern, and they come to give it to us to solve. All right. So that's what they do sometimes. If you check, most of these questions have been there in most of the exams you wrote in the past, or that have been done in the past. So these are some of the questions in definite integral. But I'm not going to stop here. I'm still going to give us the one of sine. This is just for algebraic expression. What about the one for trigonometric expression? What about the one for trigonometric expression? Please, I want you to subscribe. If you haven't subscribed, do it to smash the subscribe button. It's right there, okay, with you. Do it to subscribe. It's very important. When you subscribe, it encourages us to continue to deliver free lessons online. Okay, we burn a lot of data, we do a lot of things. Okay, just to make sure that instead of you looking for paid lessons because of JAMB, you are able to get free lessons here, and that is better for you. Okay, thank you very much. Now let's go to the next one. This one is on trigonometry. Yes, trigonometry. So I'll solve 2 questions on trigonometry. But before then, let me show you something about definite integrals. Definite integrals. Yes, that JAMB brought. Remember I told us to learn definite integrals. Look at this question. Just let's pay attention to this question, okay? On definite integral. JAMB just wrote that, look at the question from JAMB. JAMB said, or JAMB wrote that its candidates should evaluate this. Evaluate integral sec square x dx. Okay, sec square theta d theta. You see this? This question does not take up to 1 second. It doesn't take up to 1 second because you already know the answer, right? The answer is in standard integral. Okay? The answer to this question is among the list of standard integrals. So what should be the answer to this? You don't need to even bother yourself. Okay? So when getting the solutions, what is the answer to this? Sec square theta d theta. So what should be the answer to this kind of question? Yes, I want to know in the comment section. What should be the answer from standard integrals? Yes, and nobody has started it since we started this class. I want you to be the first to chat me. Chat me so that I can say shout out to you, to the entire world. Please, I want you to chat me off. Let me know what is the answer to this, the integral of sec square theta, before we go to the standard integral that will lead to this, or definite integral. When it's standard integral, then we'll go back to definite integrals. So what should be the answer? I want to know. Yes, somebody should chat me up now. Chat me up, let me know. Okay, I want to know who is with me right here so that we can all be working together and moving together. Okay, you don't want to chat me. Why? You don't want to chat me. Why don't you want to chat me? Okay, let's move on then. Let's go ahead. This is quite simple, okay? This is tan theta. Yes, that is the answer. Tan theta plus the what? Yes, this is the answer. Tan theta plus k. Tan theta plus k. That is the solution to this question. All right? Tan theta plus k. It's so fast. The reason is because this value is already listed in the standard integrals. That's why I said learn the standard integrals. When you see this, just go and shade the option and move to the next question. Don't waste time at all. All right? So thank you very, very much. Now we go back to definite integrals in case we find a question like this, we'll know how to deal with it. So let's go straight to definite integrals. We are going back to definite integrals. So another question on definite integrals. Yes, very, very good. Very good. Now, this is a question on definite integral. Let me show you the question. Evaluate. We are told to evaluate this. Now look at the question like this. So we are told to evaluate sec squared theta d theta within the range. So this is a definite integral. All right, definite what? Integral. And we already know, we're already aware that this one has already been listed, right? Among the list of the standard integrals. So we just have to change this one to that list of standard integrals and handle it according to this range. All right, so let's proceed. What are we going to do? Solution. Please, if you know the solution, I need it to be in the chat box, yes, or in the chat. Just chat me up using hashtag. Use hashtag, okay, and chat me up. This is the integral of sec square theta, the theta, not x, but theta this time. So here is pi over 4, y here is 0. So if we integrate this, what are we going to get? What should be the answer? Let's move this way or this. Okay, let's proceed this way. So what should be the answer if we integrate sec squared theta? Chat me up. Remember, I just did it now. Okay, I want to see it in the chat. Sec squared theta. Just put hash. Okay, hashtag answer, hashtag question, hashtag whatever you want to say. Just the hashtag. Okay, just put hashtag, then say it, and I will receive it as quickly as possible. Okay, and I'll give you your answers immediately. Please do well to chat me up. I want to see the chat. Okay, I want to have a class that is chatting with the teachers. I hope we are subscribing. Please don't forget to subscribe. Okay, please, as you are watching, I need you to subscribe. That is exactly what makes me come back here. Okay. Yesterday I did some of you subscribe, so today I need your subscription as well, so that we can keep moving forward and pushing forward as far as JAMB is concerned, right? So now let's look at it. This is integral. So sec squared theta will give us tan theta. This is what it will lead to. Sec squared theta will give us tan theta. Then there is no need for the k. Once you get this, what you should do, draw a line like this, put 0 underneath it, which is the lower limit. Then the upper limit is pi over 4. Remember, these values are in radians. You know the values, right? 0 is 0, both in degrees and radians. This is pi over 4. Pi is 180. 180 divided by 4, 45. So what it means is that tan 45, tan 0 is 0. So JAMB gave you 0. Don't include these zeros, okay? So the trick is this: don't include the 0, just handle only the pi over 4. And you know, we are aware that tan pi over 4, which is tan 45. Tan 45 is 1. So the answer to this will be 1. So we don't need to waste time. This is already 0. There's no like tan 0. Okay, tan 0 does not, just forget about tan 0. Okay, there's no need for that. Just note this one. You get it? Note this particular one. That is tan 45. This is 0. So forget about the zeros. But it's not always that you forget about zeros. Because co-0 is not 0. You get that now? So that's why we have to be very careful. Tan 0 is 0. But co-0 is not 0. Sin 0 is 0. You need to know these tricks because the calculators in JAMB do not have it. So please do well to watch my videos on calculation, on the calculators, how to bypass JAMB calculators. Okay, I did it in a live chat. That was on Saturday. They do well. That video is already online. So do well to go and watch it and see what we did there, just to assist you, because the calculator cannot assist you. All right, don't depend totally on that calculator. So we are going to substitute. Let's substitute, create two brackets, but in this case there's no need. Just create one here and create the second one. In this second one, there's no need, just put 0, but this is already 0. It's already 0, so put 0 here, or put tan 0 if that's what you want. Okay, put tan 0, which is 0. Here, put tan pi over 4. What is pi over 4? That's 45. This is 45 degrees. Why this is? Okay, yeah, pi over 4 is the same thing here, right? So it's the same as 45 degrees. That is the hack. Once you change it to degrees, you start seeing it clearly. You start seeing the picture very, very clearly. But if you don't put it this way, you won't see the picture clearly. So that's why I advise students to change the pi in radian. This pi is in radian. Change it to degrees. Tan 45 is 1 minus 0. So our final answer is actually 1. So this is what you are going to shade in the option. If something similar to this comes out, okay, you shade. If something like this comes out, shade it. If you change it to pi over 2, it becomes tan 90. Okay, tan 90. What is tan 90? So that is what I'm telling you to go and find tan 90. Have you seen tan 90 before? Okay, so that is exactly what I'm telling you. Now let's proceed to the next one. I hope this is very clear, because I want you to understand every bit of what I do here. So this is the first trigonometric integration based on definite integrals. Okay, I'm going to solve the last one here. Then we'll now go to the last part of this class. The last part of this class, which is on application of integration. That will be the end of the class, okay? But for now, let's take the second question. Or the second question, yes. Please chat me up. I need you to chat me, all right? Do it to chat. Let's know where we are going to. Thank you for the likes. Thank you for the likes. Thanks for the likes. Thanks for the likes. You are liking the video. Thank you very much. Then I need you to ask me questions, okay? Chat me, yes, or wish me hi, no, and so on. Let's see how we are going together. All right, I appreciate you a lot for everything you are doing. You are such wonderful viewers, audience. Thank you. My audience are fantastic. Yes, YouTube knows that, and the whole world is aware of that. So let's proceed to the next phase. Let's look at this one, this particular one, which is very, very interesting. Please do well to watch to the end. I'll show you some other very dangerous tricks that you can use, that you can use to squash JAMB, as in totally bring them to their knees. Okay? Yes, I'm going to show you that, but you have to watch to the end to get all of this. Make sure you watch to the end. Now let's proceed. Let's look at this. Let me look at something very simple for you to look at, so that we can from there proceed. I got something here for you. Determine the value of, look at this. This is another question, very powerful question. A very powerful, tricky, but easy question, like the ones we have just done. Determine the value. Determine the value of this integral 0 to pi over 2 of minus 2 cosine x, then dx. So this is another one. Let's look at this critically. We already have minus 2 here, and we are integrating, okay, within this range. Remember, that 0 is here again. Remember, the first one was tan of 0, which gave us 0. But the cosine of 0 is not 0. Use your calculator, press cos 0. Cosine of 0 is 1. Okay? Yes, cosine of 0 is not 0. Please do well to understand that. Cosine of 0 is not 0. It's 1. So let's look at it. Let's proceed. What it means is that this minus 2, bring it outside. We don't need it inside here. Okay? So this is what we are going to work on. This becomes minus 2, open brackets. Then integrate this one. Okay, let's integrate. We can forget about the bracket, don't worry. When you integrate cos x, let us integrate cos x, right? Integration of cos x gives us sine x. Will it be plus or minus? Will it change to plus or minus? Cos to sine, cosine, cosine. Remember I told us cosine will be positive. Cos to sine will be positive when we are integrating. But sin cos, okay, it's an abnormal way to pronounce, right? Sin cos, it doesn't make much, okay, it doesn't make much sense, right? That's why it will be minus. When you are converting from sin to cos, sin cos, when you are integrating. But in differentiation, it is the opposite way. All right, so that's sine x plus k, right? I don't want to put k because I have 0 to pi over 2. Instead of putting k, put something like this. Here, 0. Here, pi over 2. Yes, this is where the work begins. This is where we start working. So let's work by substituting. This is minus 2, so don't put minus 2 inside. Bring it outside and put this bracket. It's a very long bracket, please. Okay? It is the principal bracket, the main brackets. Inside here, we are now going to bring in 2 brackets with minus. 2 brackets. Then both of them we have sine. Both of them we have sine. And both we have sine. You see what JAMB has done now, right? Which means you can also forget about the 0. Remember I told us that sine 0 is 0. Sine 0 is 0. Okay? Sine 0 is 0. So, and we have 0 here. We have 0 here. Right? We have 0. Okay, we are starting with pi over 2. Let's look at it this way. Because of space, permit me to bring it here. I'm going to bring it here. Minus 2 will be outside with the big bracket, right? Then we have 2 brackets inside before this one. But for JAMB, don't bother about 0. Look at it, sine 0 is 0. So don't bother about the zeros. Okay? You may just put 0 for fashion's sake or put sine 0. But for JAMB, don't bother about the 0 because sine 0 will give us 0 here. To give us 0. So forget about zeros. Then this is pi. Here we have sine what? Pi over 2. Pi over 2, sine pi over 2. And this is sine 0. So we put pi over 2 first, then sine 0. Don't forget that there is minus 2 outside these principal brackets. Then the question now is, what do we do? Remember, our minus 2 remains minus 2. Then with this main bracket, what is sine pi over 2? I told us to always change it to degrees. This pi over 2, pi is 90. Please take note. Pi is equal to what? Pi is equal to 180 degrees. Pi in radians is 180 degrees. So if you have pi over 2, that is this pi over 2. Pi over 2, it means we have 180 over 2. That's what we have. It means 180 over 2. And that is what? 90 degrees. It means pi over 2 is equal to what? 90 degrees. 2 pi is 360. That's why the circumference of a circle is 2 pi r. 2 pi, that's 360 times the radius. Okay, so that is what it means. Don't forget that. So I just brought this for our snappy understanding, so I can get it fast, catch it fast. So this is sine 90. Sine 90 is 1. We are going to write 1 here because sine 90 is 1 minus this 0. Minus this 0. Sine 0 is 0. So in JAMB, you don't need to bother about the 0. Just focus on this, except if it is cosine. If it's not cosine, don't bother. If it's signed, if it's tangent, don't bother. So what is the answer? That gives minus 2 open bracket 1, and that is minus 2. The answer to this question is minus 2. I hope it is well understood. 1 minus 0 is 1. Then times it by minus 2, and that is all. So this is quite simple. Please, I need you to comment. I need you to share. I need you to like. Thank you for those of you already liking. I appreciate you a lot because I know that you are trying to help the system grow. So I appreciate you. I now have 8 likes. So thank you very much. If you have not subscribed, please, and you're watching, I want you to subscribe because your subscription is what pushes this thing forward. Okay? If you don't subscribe, the channel will not be growing. So your subscription will make the channel to grow. So I appreciate you a lot for even coming at all to watch. We are very much grateful. And AZ Science TV appreciates you a lot. And we pray for you to succeed every day. So that's what AZ Science TV is concerned about. And please, if by tomorrow when you pass the exam, please, I want you to come to AZ Science TV and give testimony of how you succeeded after watching our content and the rest. Okay, we want you to also come and share your testimony with us so that we can all be happy together. So this is the last part of definite integrals. We are now going to look at application. Some of us don't know how to apply integrations, but we know differentiation very well. We know maximum and minimum points. We know gradients. But when it comes to the other case, when it comes to this other case for integration, we find it very difficult. So we are going to work on that now. Let's look at how we can apply integration. So how do you apply integration? This is what we are going to be looking at today. So thank you very much for watching. Let's proceed to the last part of the class. We are very much hot now. We are the peak of the class. I will give you 5 hacks, 5 dangerous hacks you will use to defeat JAMB this year. Score high in maths. Okay, I will teach you all of that so that you don't get confused when you get to the exam hall. So, application of integration. So let's look at the applications of integrations. So how do we apply integral? Yes, yesterday we dealt with how to apply differentiation. Now today, let's look at how to apply integration. Very, very important. So let's look at the first question. The questions are word problems. So permit me to write it down. I'm going to write it for you to see. So question. The gradient of a curve . The gradient of a curve is is 2x plus 7. Is 2x plus 7. And the curve passes. And the curve passes through the origin. Through the origin. Okay, and the curve passes through, sorry, not through the origin. And the curve passes through 2, 0. These are the points. Passes through, okay, and the curve passes through 2, 0. This is not origin. I will give you the one of origin later. Find the equation of the curve. Find the equation of the curve. This is the gradient of the curve. This one here is the gradient of the curve, not the equation of the curve. Then we have to find the equation of the curve. All right, I hope we can find the answers, right? Yes, the gradient of a curve what is 2x plus 7, which means after it has been differentiated, we got this. And the curve passes through this coordinate. This is a position in the Cartesian plane, okay? And it has coordinates, x coordinate 2 and y coordinate 0, which means y is 0 here. Find the equation of the curve. Now, I want to show you something that you need to note here. This is dy dx. This one here is dy dx. So you are going to integrate this dy dx, okay, to get the equation of to get the curve. Then when you integrate it, you add k to it. We are going to find that k by substituting for x and y. We'll get the k. All right? Then after getting the k, we'll come back and substitute the k. After substituting the k, whatever we get is now the original equation that was differentiated to get this. Is that taking? So if you are following me, let me know in the chat box, please. Okay, right? I'm following you. Let me know if you are actually following me. Okay, I want to be sure that we know that we are following each other. Thank you very much. Now, let's look at the solution. We are not going to waste time here. This one does not need time wasting at all. Question 1, 2x plus y is the gradient. Look at it, gradient. So yesterday, we said gradient. Gradient is dy dx. So that's gradient. So we are going to write gradient. Gradient. Gradient is given as what? Dy dx. This is dy dx. And dy dx is given to be what? 2x plus 7. So write 2x plus 7. That is dy dx. That is the gradient. The gradient of a curve is 2x plus 7. So gradient is dy dx and is 2x plus 7. Do you get it now? So what it implies is that we are going to write dy. What is dy? Look at it. dy is now, this is 2x. Bring 2x this way. Bring 2x and dx. Bring dx this way. So we have dy equals to what? 2x plus 7 brackets dx. That is dx here. Can you see it now? That's what we have here. Which means if we integrate dy and we integrate this here too, right? Let's bring the integral here and here, which means we have y is equals to the integral. The integral of dy is y. Don't forget, this is like integral 1. So if you integrate dy, you get y. And this is equals to what? What we have here. What do we have here? We have 2x plus 7 and dx. That is what y is. That is y is equals to the integral of this. So let us integrate this one. That is the implication. So let's integrate it. If you integrate it, what do we get here? So permit me to draw these lines this way. Okay? Yes. So integrate 2x. We are going to get 2x squared. That is y is equals to 2x squared. Then plus 7, right? Don't forget this is 7x. And here is over 2. So you increase the power of x by adding 1 to it, then divide by the total power, okay, which is 2. And we know what has happened here. What happened is that these 2 cancel these 2. Is that taken? Don't forget our k. Our k is here. So that's what we have. We have plus plus k, which means our y will now be x squared minus 7x plus k. X squared plus 7s, x squared minus 7s plus k. This is, once we get the value for this and we substitute here, that becomes the equation of the curve. Is that taken? That's what it means. So let's proceed. Let's see. What is the equation of the curve? Come here. Since we have gotten this, we are going to use this expression here. Look at this expression here. This is 2 and this is 0. So we are going to substitute for x and y. This is x and this is y. So where you find y, put 0. And where you find x, put 2. Look at it here. 2 here, 2 here. So substitute. If we substitute, we are going to get, what are we going to get? We'll get y. Yeah, y is 0 equal to, this is x. X is 2. That is 2 squared minus 7, open bracket. What is x? X is still 2 here. So write 2, then plus k. The purpose of this is to enable us find that arbitrary constant that I said at the beginning of this class. Okay, that's why it's good to follow the class at the beginning. But if you have not followed, I will go back and explain it. That will be the summary of the class. Okay, when we are done with all the applications, I will summarize the class. Okay, so don't worry. If you have missed it from the beginning, I will go back and then refresh our memory, okay, through a summary class. Can you hear me now? Please, if you can hear me, let me know. Okay, if you can hear me, let me know in the chat box, please, because the mic went off. I want to know if you can hear me, please. Okay, if you can hear me, let me know. Put it in the chat box. Can you hear me, please? I want to know if you can hear me, because the mic went off initially. So I do hope you can hear me now. So let me quickly summarize, because you didn't hear me before, but I hope you can hear me. Please, in the chat box, let me know. Okay, or in the chat, just put hashtag I can hear you, hashtag I am with you, hashtag the sound has been restored, hashtag sound is back. Okay, so that I will know if you actually can hear me now. Sorry for that. I duly appreciate you for your for not going, even though you can't hear me, but you were still with me. Now, the gradient is this. Okay, so and we integrated the gradient to get the expression. This is what we got. And once we integrated this one to get this, we are going to find k by coming here to substitute for x and y. 2 for x, 0 for y. So this is y, 0 is for y. Then x is 2, look at it, x is 2 here. So this is 0 equals to 2 squared is 4 minus 7 times, okay, 7 times 2 is 14. So bring in the 14 here, 14 here, then plus k, plus this k here, bring it here, k will be here, all right? Then it means that we have 0 is equals to 4 minus 14. 4 minus 14 is minus 10. Minus 10. Then plus k. Minus 10 plus k. So take minus 10 to this other side. Okay? If you transfer minus 10 to this other side, it means we are going to have 10 equals to k. Okay? Because when minus 10 is crossed, it changes to k. The implication here, the implication is that our k, it means our k is equals to 10. That is the implication. Therefore, k is equal to 10 because k is equal to 10 here. Just look at it. What are we going to do? Remember, we are to find the equation of the curve. So to find the equation of the curve, we are simply going to substitute for k in this expression. So in this equation, what is the equation? Please permit me to quickly, so the equation of the curve, equation of the curve, equation of the curve is equals to y is equals to x square minus 7x minus this 7x, then plus k. What is our k? Our k is 10. Okay, so substitute here. This is the solution to the question. Yes, this is the first question on the application of the integration. We can restore an equation if we know. We can restore an equation from the gradient if we know one of the coordinates where it passes. So we can always restore the equation. Do you understand? That arbitrary constant that was k, we have gotten it back, which is 10. Remember, I told us before that when you differentiate a constant, like if you differentiate this one now, 10 will disappear. And when you integrate it back, you won't get the 10 again. The only way to get the 10 back is when you know the coordinates. One coordinate at all, one point, the coordinate of a point. That makes it easier for you to get it back. So we have gotten our 10 back. So congratulations to this equation, because the equation has gotten its 10, its constant restored. So there's no arbitrary constant again. It is now a definite constant, which is 10. So thank you very much for being here. Do well to like and share. Okay, don't forget to subscribe. Those of us who have not subscribed, please do well to subscribe. If this video is making sense at all, if the video is impacting you or anyone around you, please do well to subscribe. I need you to subscribe because I'll keep coming here when I see the subscription increasing. All right? But if not, you know that it will be discouraged. But I don't want to be discouraged. You are the one pushing this channel forward. So, and I want you to keep moving forward. And I'll keep coming here to make sure that you benefit a lot. So if you understand this, I want you to put in the comments, in the chat box. Okay? Tell me that I understand this. If you don't understand, if you want me to re-explain it, let me know. Okay? I'm not just here to talk to myself. I'm here to talk to every one of us. Please, I want us to talk to one another. Chat me while I do the voice, then you do the chat. I'm always checking the chat box, okay? So when I come there, I will check the chat box to know, not necessarily the special chat box. Put hashtag, okay? Hashtag, I do not understand this step. Hashtag, how did you get this? Hashtag, what happened here? You know, hashtag, please treat this next topic. Hashtag, okay? Just put hashtag and I'll come and check it. Now let's go to the next one. I need you to see this. This is very, very interesting. Yes, this is very interesting question that a lot of students may be finding it difficult. And when you find a question like this, just know, if a question is telling you to restore an equation from the derivative, just know that what they mean is that the gradient has been given, dy dx have been given, and you are to restore it to the original equation like we did here. Okay, please don't forget that. So are you there with me? Please do well to chat me. I need you to chat me. Okay, it's like my audience today are not ready to talk. I hope it is okay. Please, okay, it's all right. Maybe we just want to be reserved today. I appreciate you for that. And the kind of audience I had yesterday, we are the one that were chatting with. I don't know what happened today. It's like I have a different audience today. Thank you very much for joining. I appreciate you for even staying to this time. It means you are committed to success and excellence. That's why you are at azsciencetv. It's your success, your exam success partner. That is who we are, and we are ready to make it a reality. So let's look at this question under applications of integration. Now, this is a very simple question again. Okay, we are given here that a function f of x passes through the origin. What is the origin? At the origin, x is 0, y is 0. So we are going to use that to find the equation of the function, or to find the function. Okay, we remember the first one, we found the function when we are given the coordinates. Here we are also given the coordinates. Well, anytime you hear the word origin, it means y is 0, x is 0. That is origin. Don't forget that. We are going to treat it. So this is a very typical question on the application of integration. So let's look at it. It's another here. JAMB follows this pattern. You can see the pattern repetition, right? Good. They didn't change anything. They only change origin, okay, the coordinate to the origin. After all, this is dy dx. So it's the same thing, all right? This is dy dx. So they change the other coordinates to the origin. Now let's proceed without wasting much time. Solution. Remember, derivative. I don't know if you have heard this word. Have you heard this word before? Derivative. What is derivative? What does this mean? Derivative. Derivative means differentiation. It means what? Differentiation. That's what derivative means. All right? It means dy dx. Okay? So who can help us? Who will tell me what to do next? Yes, I want to know who will tell me exactly what to do next. And please tell me. Please do well to like and share. Okay? Like and share this video. Don't forget to share this video. It's very important. Okay? So I can see likes. There's some of us are watching. You're not liking. Please. Okay? If you have not liked this video, do it to like the video. Okay? And most especially, I want you to subscribe if you haven't subscribed. azsciencetv is very much happy to have you as one of the viewers if you have not. But if you have subscribed, thank you very much for subscribing. I appreciate you for your subscription. Just look at the base at the bottom of the screen. You see subscribe. Okay, just click on subscribe and turn on notification bell so that whenever we are online, YouTube will always notify you. Okay, so without wasting much time, I don't want to take much of your time because I know you have so much to do during this JAMB season and the examination seasons. Now, a function f of x passes through the origin and its first derivative. First derivative means dy dx. That's first. Dy dx. Second derivative means the square y, dx square. This is second derivative. Third derivative means the 3y, the cube y, dx cube. You see that? This is first. This is first. This is second. And this is third. This is first. First derivative. First derivative. That is, differentiate first time, that's first. Then if you differentiate again, that's second. But we don't need this one. This is what we need, first derivative. We don't need these two. And that first derivative is the gradient of the function. Please don't forget that. It's the gradient of the function, or dy dx. So that is what we are going to work with now. First derivative. So let's focus on this now, on the first derivative. So I'm going to write first derivative. First derivative. First derivative of the function is equal to what? Okay, yes, first derivative, that is dy dx, and that is equal to what? 2x plus 1. This is the first derivative. This is what we have. Now, what are we asking? They are asking us to restore the equation. Okay? So how do we restore the equation? This dy dx, please, is the same thing as, I don't want to bore us, okay? This dy dx is the same as f prime of x. Is f prime of x. Yes, f prime of x. Don't forget, f of x is what we are looking for. The dy dx is f prime of x, and is equals to 2x plus 1. Yes, that's what it is. Note this because it may come in different pattern. Okay, this is f of x now. The other one is like dy dx, gradient. Gradient. Sometimes they may even say maximum or minimum points. They may bring it here. Yes, it can come in different forms. So be sure that you are very much prepared for them. Okay, now if we have this, what is y? Y is the differential. Y is the integral, not differential, sorry. Y is the integral of, y is the same thing as f of x. Don't forget, y is f of x. F of x is y, and it's equal to the integral of 2x plus 1 dx. Yes, this is what f of x means. It is that f of x that we want to look for. Okay, that's what we want to look for. So integrate this one, it will give us 2x square divided by 2. Same pattern. Repetition. You can view repetition here, right? You can sense repetition from here. Then plus this. Integrate 1, we'll get plus x. Then arbitrary constant, k. It is this k that we are looking for. Once you get this k, come and substitute it in this expression. It means you have gotten the answer. Let's proceed. This gives us y equals to, sorry, let me move this one a bit. Okay, it's not moving. Sorry, let's proceed. 2, we cancel these 2, right? And that gives us x squared plus, so we are done with this, x, then plus k, this arbitrary constant, k. Remember, we went back to the question before, right? To the other question. Now we are coming back to this question, this particular one. Origin. What is origin? At the origin, at the origin, okay, x, the coordinate x, okay, let me write it here. At the origin, the coordinates x and y are both zeros, okay? At the origin, x, comma, y, s, comma, y is equals to 0, 0. Look at it here. S, comma, y. So x is 0, y is also 0. At the origin, please don't forget, at the origin, we have this. Okay? Now we are going to substitute into, we are going to substitute for x and y into this expression. We substitute for x and y. So let's substitute. This is y is 0. So write 0. We are going to write 0 here. Equals to x is 0. 0 square. So we are going to write 0 square here. Then plus x is 0 here. We write 0 here. Then plus k is not x, it's not y, it's a number itself. So we call it k. From here, what should be the value of k? We don't need to waste our time. In JAMB, we don't waste time. So k is equals to 0. Therefore, k is equals to what? 0. That's what it means here. It means that our k is equals to 0. If k is 0, what is f of x? F of x. Because k is 0. So, and this is y. This is y, or f of x. This is f of x. So f of x will now be what? Since k is 0, f of x is equal to, so somebody should tell us what is f of x. Put it in the chat, okay? Hashtag f of x equals to this. Let me hear from you. Let me still see your chart, okay? F of x equals to, all right? Please, I want to see it in the chat box. So what is f of x? Do me a favor, put it there. Look at it. B is already 0, so what is f of x? That's the final answer. Anything you get is your final answer, okay? F of x. So what is f of x? Have you checked? Have you checked? F of x, I want to know. Yes? Who is on my side? Yes, f of x. What is f of x? That is the final answer. Okay, what is f of x? So we want to find f of x here. Because we already know that k is 0. Okay, so for the last time, let me check. If no one is responding. Okay, no one is responding. I have not seen the response. Why are you not responding? My audience today are very wonderful people. Yesterday, my audience were chatting me as in back to back. But my audience are very calm and reserved. Okay, I appreciate you for that. At least you are still with me after this long while. So, f of x square will be x square here, right? X square. Then plus. Okay, this is f of x, don't forget. It's x square plus x. No more k. Why? Because k is 0. Look at it here. K is 0. So, plus x, then plus k. What is k? Our k is 0. Our k is 0. So, which means that our f of x, which is what we are looking for here, f of x is what we are looking for right here. So, our f of x is actually x squared plus x. Yes. Yes. Somebody say, yes, I know this. Yes, I knew it was like this. It was going to be like this. You are correct. If that's what you're thinking, you are very much correct. So thank you very much for thinking that way. Okay, even though you didn't chat me, no problem. I know you are still there. Okay, but if you're not interested in the content, you won't be there by now. So for being here alone, it means that you're actually interested in the content. Maybe you don't want to talk to me, no problem. Okay, so this is exactly what the answer is. A function f of x passes through the origin. At the origin, x and y are zeros. And its first derivative, that is the y dx, is this. Is 2x plus 1. What is f of x? So what you simply have to do, integrate this function, integrate the function here. This is not the actual function, this is the derivative of the function. Integrate this algebra. When you integrate it, you get y equals s squared plus x plus k, and that is f prime. No, okay, that is f of x. Okay, that is f of x. Then substitute using the values of x and y at the origin. So the values of x and y at the origin are 0 and 0. So come here, substitute for y. Y is 0. That is y here, which is 0. Then x is also 0. So this is 0 square plus 0, then plus k. 0 square plus 0, then plus k. Then we know from here, because everything here is 0. Therefore, k is 0. Go back, okay, we are going to go back here. We are going back to this expression, okay, to substitute for k. That gives us f of x equals x squared plus x plus 0, because k is 0. This k here is 0. So it means we have x squared plus x, which is x squared plus x. So 0 means the value there has disappeared. That is what it means. So I hope we got this correctly. I hope there was no confusion, right? Is there any confusion? If there's a confusion, let me know. Yes, any confusion? If there's nothing, if there's something you don't understand, let me know. I want to be sure that we understood this. Yes, any question? Okay, now we'll take another question from here. Another question. Okay, let's look at this one. Is based on area. Area. This is based on area. So please, I want your chart. I want you to talk to me. Talk to me. All right, talk to me. Let's see. Let's hear from each other. Just chat me hashtag anything. Let me know what you are thinking about the class. What question do you have? What are your most difficult aspects? What topic should we treat next? Because this channel is not mine, it's ours. Okay? Yes. So let's look at this part. We are going to look at this area. Yes, this is question, another question. Yes, question. So we have a question like this. Find the area bounded, find the area bounded by the curves. So there are two curves here. So we have to find the areas bounded by the two curves. All right? Yes, that's what we are going to deal with right now. Okay, let's proceed. What will be the solution to this? How do we handle this? These two curves are bounded. Find the area bounded by these curves. Yes. What are we going to do here? In this case, we have two y expression, right? Which means we are going to add it together, okay? We are going to equate these two expressions. We'll combine it together to get the solution. If you have an idea, let me know in the comment section, right? Yes, because I know most of you are scholars here, even though some of us are very reserved. We don't want to chat me. Please, if you have any other way to solve the problem, let me know in this comment section or in the live chat. Rather, I keep using the word comment section. I actually mean the live chat. Yes, let me know. This is solution. So this will be the question we'll solve. And I'll tell you the tricks that you have to use so that you don't waste time in exam halls. Okay? So what it means is this. It means we have this one. This is 2x plus 1. Okay? Equals to 4 minus x squared. 4 minus x squared. This is what we have. All right? It means we have this and this equated. We have equated the both of them because both of them are y. They are both y and y. So equate the both of them like this. Since both are y. So collect the terms. Put all the terms together in one side. That's bring this minus x squared here. Becomes x squared. Then this is plus 2x. Okay? This is plus 2x here. This is minus x squared. When it comes here, it becomes x squared. Equals to, no, not equals to, we are not done yet. This is 1. Okay, this is 4, which is plus 1 minus 4, equal to 0. I'm sure this is understood, right? This is x squared, which is this minus s squared. When minus s squared is coming, changes to plus s squared. Okay? Then, what we are going to do next, just subtract from here. That gives us x squared plus 2x. Then 1 minus 4 is minus 3. And it's equals to 0. What do we notice here? This is quadratic, right? Yes, this equation is quadratic. This equation is quadratic. So we are going to solve this equation quadratically. And the best method is factorization. Yes. JAMB always, in fact, 99.99% of his questions are usually factored, especially quadratic. The quadratic ones are usually factorizable. Okay, there is no way they will give you a question that has no factors. It's very difficult to get that. I'm not saying you won't get it, it will be very difficult. Now, this is what will happen. Just open two brackets. Some students will be wasting time. Don't waste time. Don't waste time trying to figure out what will happen here. Nothing will happen except do you know that the first, let me tell you the trick for this. This will shock you. The major thing you should look at is this one. Look at this 3. Do you know that 3 is a prime number? Yes. Since 3 is a prime number, come and put the 3 here or here, anywhere. Put the 3 anywhere. Let's put it here. And here we have 1. Remember, we are always multiplying the number here with here, right? 1 with a prime number. A prime number has only 2 factors, itself and 1. So put 1 here. Then we don't know whether here will be minus or plus. Let's check. How do you know if here will be minus or plus? It's this place that will show if here will be minus and plus. Okay, 1 will be minus, 1 will be plus. We don't know the one that will be minus and one that is plus. But what is here? This is minus. Minus means that it is minus times plus or plus times minus, because minus times plus gives us minus and plus times minus gives us minus. I don't know if you understand. So it means that 1 will be minus, 1 will be plus, or 1 will be plus and 1 will be what? Minus. So there must be minus 1 here, there must be minus something here, and plus something somewhere here, or plus or minus here and plus here. So that is why there is minus here. Remember, it is product or times that gives this quantity. Then it is summation that gives this. And since this is a prime number, it means that only 2 numbers can be combined to get this by products, and that is 1 and 3. That's why you can see me putting 1 here and 3, right? Good. Now the question now is that, you know, we have x and x here. So let's put x and x here. You get it? We have x and x here. Oh, okay, let's remove this one first to avoid confusion. Yes, we have x and 1, x and 3. That is number 2 trick, because it's only x that is here, so we have x and x here. This one is because what we have here is a prime number, so no need to bother ourselves. Just put 3 and 1. Since it's prime numbers have 2 factors only, and that is 1 and itself, any prime number at all. So that is 3 is a prime number. It has 3 and 1 as the factors. Now, how do I know that it's minus and plus? There must be minus and plus to get minus, to get this minus. How do I know? I will come here. This is how to know. Any sign that is here, give it to the bigger number. Does that make sense at all? Am I saying anything reasonable? Anything that is here, give it to the bigger what? Number. So, which means here will be plus, and the small one will carry the minus. And when you add these two together, minus 1 and plus 3, you will get plus 2. That is how to get it. We have already factorized. So you can use this method, this trick. Okay, it will not waste your time at all. Okay, use this method, you'll get the answer straight. Now that we have gotten this, remember, the purpose is for us to do what? To find the area. And the area can only be gotten by integration. But before then, let us find the values of x and y. So from here, what is x and y? As a JAMB student, as a smart JAMB student, what is x and y? Do you need to be saying, let x equals to this, let x minus 1 equals to 0, let x plus 3 equals to 0? No, because there will be no time in the JAMB hall. This is what we are going to do. Just write that x is equals to, this is equal to 0. So just transfer minus 1 this other way, becomes 1 or plus 1. Okay, then what about the other x? Or X is equal to what? X is equals to, this is plus 3. Transfer it to other side. Becomes S equals minus 3. JAMB. Yes. That is the answer. Don't need to be doing all of that. There's no time. Just follow the shortcut. Remember, the journey is still far. And you must solve this one and get one of the marks. Okay, I don't know whether it's 2 or whatever, but you will get one of the questions. So don't waste time. I'm just going slowly because I want you to understand and understand better. So let's proceed. Now that we have gotten our value here, you know what we'll do? We'll now come to integration. Okay, to integrate so that we can get the area. Area is now the integral. Integral. What's the integral? The integral of this one. Use this one, please. Don't use half. Use this one. Make sure you use the integral of x squared plus 2x, then plus, okay, minus 3, then the x. This is how to get the area. But remember, it's a definite integral. So we'll start from 1, okay, minus 3, and 1. So this is how to get the integral. So can someone do it now? Okay, what I want us to do is to integrate this one, then substitute and get the difference. That is the area. That gives us the answer to the question. All right, so I want you to help us to find it. So who can help us find the area of this, of the area bounded by these two curves according to the question? So I want to see it in the chat area or chat session. Please do well to chat me. I want you to chat me. Okay, so please do well to chat me. Yes, who is chatting me? Liking the video is going to be appreciated a lot. Okay, then do well to subscribe. Okay, I hope all my viewers today are subscribing. Please subscribe. I'm still seeing some viewers who have not subscribed. Please, I want you to subscribe. Okay, just subscribe. Click on the subscribe button. It is just below the live stream. You will see subscribe there. So do well to subscribe. Turn on notification bell too, so that YouTube will always notify you whenever I'm coming online. Okay, you don't need to bother yourself searching for AZ Science TV. YouTube will just notify you that AZ Science TV is online. Please come and join the live stream. Or when I post a video, it gets straight to you without missing anything. Okay, so have we gotten answers now? Yes, who has given me an answer? Okay, I have wonderful audience today. Okay, audience that are very wonderful. Thank you very much. Appreciation to every one of you. Yes, so this is what we are going to do. Let's integrate this. If we integrate, we are going to have x raised by 3. X raised by 3 divided by 3. For only this, add 1 to the power, that gives 3. Then divide by the total, which is 3. Then plus, do the same here. It will be x squared. Remember, it will be x squared divided by 2. And there's 2 here, right? So these 2, we cancel these 2. Okay? If these 2 cancel these 2, it will not be left only x squared. So there's no need for all of this. Remember, we have done it over and over again, right? Good. Now, the next space is here. That's minus 3x. Then put in this sign. No need for decay. Okay? Just put minus 3 here, which is the lower limit, and put the upper limit. So that is what we have right here. Then once we are done with this, we can go ahead. Remember, it's area. So create the brackets. Start with 1. Start with 1, put it here. Then the next one, put it here too. Okay? So let's proceed. 1, use 1 here. That will be 1 over 3. Right? This is 1. Look at it here. This is 1 raised by 3 divided by 3. Then plus 1 square. 1 square. Then minus 3 bracket 1. That is for the first number here, the upper limits. The upper limit is 1, while the lower limit is -3. You can try it too, and even get the answer before I get there. Okay? I'm more than happy to have you. Please, I want someone to chat me before this live stream ends. I don't want to end this live stream without your chat. Please, if you want me to be happy after this chat, please, I want you to help me out, okay? Your presence here has been very wonderful and has been integrated into this class. So I'm going to be very happy if at the end of the day, I see you say, I see your hi, or anything, just chat me, okay? I need you to be here with me. Now, let's proceed. We're in -3 now. So -3 raised to power 3 will give us -27. Remember, the minus will remain because it's an odd number. -27/3. Then the next phase is what? Yes, let's proceed. This is square. So square, that is 9. Am I right? -3 square is 9. Remember, this is plus. So here we change to plus. This will be plus. There will be no minus because the square will cancel the minus. Then this is -3. 3 times 3. 3 times this 3. -3 times 3 is, let me just spell it 9. You get it? Look at what has happened here. Are you aware that this 9 will cancel this 9? And that's not even enough. Look at this, -27 divided by 3 is -9. So you can see how fast and easy and straightforward it is. So I'm going to clean here. I do hope you are done with this part. Or let me just finish it up right here. Okay, I'm going to clean the question. Please bear with me. I'll clean the question so that I can revise. So I can review the question or the answers. So let's look at this. A is equals to 1/3. So we have 1/3 plus, this is 1 here, plus 1. Then this is -3. Then minus, okay, minus, let's bring another bracket here. -27/3 will give us 9, right? Look at it. Remember, it is -9, this one, because these two are already gone. They've already cancelled themselves. So they have disappeared. So we now have our A to be equals to JAMB candidates. I want us to be very fast, okay? 1 minus 3 is -2. That's what it is, -2. And this is minus times minus, that's +9. Okay, this is +9. So what next are we going to do here? What next are we going to do here? Remember, I told us as JAMB candidates, we have to be, as exam candidates, we have to be very fast. We stop looking for LCM and doing this and that. There's no need for that, okay? This is what we are going to do. If I was an exam, or this is what I'm going to do. Just multiply 3 by 2. That is 6. 3 times 2 is 6. And this is 1. So this is 1 minus 3 times 2. Put your 6 here. This is the only number at the denominator. So let's close the bracket here. So close the bracket here and write +9 right here. We write +9 there. Then we proceed. The next step is for us to evaluate. So 1 minus 6 is -5. 1 minus 6 is -5 divided by 3. Then this is +9. We don't need the bracket anymore because we are done with all the multiplications. The sign for addition and subtraction. We are going to do the same thing. What we did before, do it again. Okay? What we did before, let's repeat it. Remember what we did here. 3 times 2 give us this 6. Then bring in the minus and this 1. So do it again here. Okay? Somebody should do it. Let me see. Okay? I want to see it in the chat box. Okay? Who will do this for me? Please, I want you to do it for me. Okay? Just try and see how you can do this for me. Okay, please, I'm more than happy to see your chart. At least the first chart. Just give me first chart, please. Okay, this, what I did here, 3 times 2 is 6. Then you are going to help me to do this. 3 times 9, okay? Please, and tell me what I'm going to write here. What should I write down here? Yes.